Hi, Algebra 2 students. We are starting a new unit. So unit 3 is all about linear functions. So that's why you get the cute little, line graph going on there. And we are going to be doing some graphing in this unit. But I just wanted to really quickly look at what's coming for this unit. So as you're looking at it here, we start with something called average rate of change, and we'll do a little example with that in a moment. Different forms of a line. One you should recognize, one might be new. Modeling linear functions and so on. That's going to take us over 2 days. We're skipping day 5, so you're going to notice we only go from day 4 to day 6 because we've already talked about inverse functions. But don't be surprised to see these pop back up here. Then we get to do some piecewise, 3x3 systems. These are fun. And then word problems with those, review and test. All right, so that is what's coming for this unit. Jumping right on into today. Talking about average rate of change. I like this first example just because it's actually really interesting to look at this data over the years. This is the history of the general hourly minimum wage in New York State. So different states, maybe different rules, but New York State, so what you guys are familiar with in particular, right? So when you look at it, it's giving you the date and then what is the minimum amount people could be paid here. So starting back in 1960, it was established that $1 an hour. That's what you're looking at. All right, and then it works its way through. It changes a couple times in the 60s, but not by much, $1.15, $1.25, and so on, right? 1978, that's just a touch after I was born right there. It changes from 230 to 265 when I was a kid. So my first job was like 1996-ish. It was at a rate of $4.25, but my first job I made $5 an hour. I felt very fancy. All right. The chart stops in 2017. So I just looked up, and in 2019, it changed again, and it is now up to $11.80 an hour, which it's pretty awesome if you're a kid making minimum wage, not as awesome if you're an adult making minimum wage. So just kind of depends. All right. So when it says how much was the minimum wage, right, in those particular years. So you're just looking at the chart and reading it. So 1960, it was a whopping $1 an hour. When I was born, all right, it went from in 1978, 230 to 265. So let's use the second one. So it changes up to 265. 1991 was another jump there, so 425. All right, and then 2017, the last one officially on the chart, minimum wage is up to 1040. And you guys can see, so you might have gotten a job in the last year or two, or maybe you don't have a job yet. But look how it's changed over that chunk of years from 2013, 14, 15. It kept on moving, which is pretty cool. So when it says how much did it change from 1960 to 1978, well, I just want to know, how much did the value increase? So from $1.65 went up by $1.65. From 1978 to 1991, the difference here, and you could subtract on your calculator if need be, comes out to be $1.60. And then from 91 to 2017, there's a big increase there. So $6.15. Mm-hmm. And so when it says calculate the average rate of change for each time interval, all right, when we say average rate of change, so literally on average, how much money changed, but you have to consider, right, how much did it change over the given amount of time? So what we just found right here is how much it went up. It went up $1.65. It went up $1.60. It went up $6.15. But it didn't happen necessarily in 1 year time increments or even equivalent time increments, like 10 years, 10 years, 10 years or something. So when you have to consider the average rate of change for each time interval, you have to consider how much time has gone by. So you have to figure out the change in the money, so $1.65, but that changed from 1960 to 1978. So that was over 18 years. Mm-hmm. So over 18 years on average, how much did it increase? Well, if we take that quotient, $1.65 divided by 18 years, it went up about 9 cents a year. Big money right there. All right. And then same thing for the next one. From 1978 to 1991, it went up $1.60. But from 78 to 91, that was a 13-year gap. So it didn't go up quite as much as this, but it went up faster because it was only in 13 years. So if you take $1.16 divide, it comes out to be about 12 cents per year. So it's a little bit of a faster rate of change. And then the last one, $6.15 increase is definitely the biggest increase here, but over how much time? So 91 to 2017, right? That's 26 years right there. So it's the biggest change, but also the biggest amount of time. But if we take 615 and divide it by that 26 years, it's still going to be the biggest, whoops, move it this way, the biggest rate. It's about 24 cents a year. So almost an extra quarter per year, right? So when it asks you for the biggest rate, rate has to be a comparison. So in this case, it's the amount of money per time. Then the biggest rate of change here would be this one, right? But what this should kind of seem similar to when you're comparing, the rate that one thing changes to the rate that the other thing changes, that is actually something that when we graph, that is representing the slope. Now, when we think about slope, right, we think about change in y over change in x, which is that little delta right there. You might have learned it as rise over run. But if you think about it in this regard, I'm going to come back up to my chart for a second. Time is always the independent, the x value. And then y is whatever is depending on that. So it was how much the money changed over how much time had gone by, the change in y over the change in x. So when we were asked for the average rate of change of the minimum wage, it was essentially asking you for the slope of this data. Now, if we were to graph this, it's not perfectly linear. What we would start to see is we would see that, it increases and it increases a little bit more, and then you see a steeper increase. So the steepest slope matches the biggest rate of change here. Right? With that being said, when you flip it on over to the next page, here, when it's got a little intro to it, we're actually going to skip over some of these parts because I forgot that we had the first page and we don't really need this. So let's skip this page. If we have time in class, maybe we'll come back and we'll take a look at it, right? Otherwise, I actually want to jump all the way over to where you have a blank page because this is one of those units where we're taking a little bit of our own notes. And because most of the notes are in the packet, I just included some blank pages so that we'd have some space to put those notes in versus having stuff all over the place, all right? So day one, our focus here is on average rate of change. All right. So what we just said there a second ago, the average rate of change is how fast a function changes on average over a certain domain. So over a certain domain is pretty important because if it's linear, then it's going to be the same rate of change. But otherwise, if it's not a linear function, you're going to see it kind of change throughout, right? So there's a couple ways you can write this. One way, oops, I'm sorry, guys, I'm a little crooked here. Let me slide up. One way is to think of it as slope. And so in terms of slope, we say change in y over change in x, which essentially means y2 minus y1 over x2 minus x1. Right? You will sometimes see it, and this is kind of like a pre-calcy way to show it, is to say for an interval where x goes from A to B. So imagine those are like the little endpoints of a particular line. Then what we would say is that the change in f of x, so our function, over the change in x would be given by how much the y values change from A to B. So we write that as f of B minus f of A. And then all over the change in the x's, well, B minus A. Okay. These two things mean exactly the same because anytime we use f of x or f of anything, those are y values. And then in this case, b and a, we're setting those as x values.